Hola, today I'm going to talk about passive house design for a house called Casa Familia in Barcelona. It's a house that I designed based on the project's requirement. But first, I want to talk about and explain what is passive design in architecture. Passive design in general means is to achieve thermal comfort in the space without or with minimal assistance from the mechanical systems by taking advantage of ventilation, daylighting, thermal mass, shading, and etc. Why is it important? Building sector is demonstrated to be one of the strongest drivers of greenhouse gases to our environment. Hence, the rapid urbanization in the world outcomes large amounts of CO2 to our environment, unfortunately. The location of the project is Barcelona, Spain. It's located in Europe. It has a population of 1.62 million. To choose wisely the passive design strategies, the location characteristics should be analyzed well, as every location or climate requires different passive strategies techniques. So now, in coming slides, we will analyze the characteristics of Barcelona, Spain. Architecture in Barcelona is very unique, as it has so many types of architecture, but most importantly, it houses a lot of Gaudi's masterpieces, and it also has Barcelona Pavilion, which is a modernist architecture, but done by Mies van der Rohe. The first characteristics that we're gonna investigate in Barcelona is the temperature or the weather. So the temperature diagram below shows that it gets really hot in summer and it gets cold in winter, but not very cold. In summer, it becomes maximum of 31 degrees and becomes minimum of 7 degrees in the winter. Wind direction and speed. Most wind in summer is directed from east and south, and most wind in winter is directed from west and north. Plot location. The area of the plot is 1,300 square meters, which is like 27 meters by 50 meters. It's located on a street called Carrer de Can Farel, Lilac de Mont in Barcelona, Spain. If you can see in below images that the plot is located on a main street and is very close to a crossroad. Below is the sun diagram of the plot. It is very important to mention that considering solar orientation in passive house design is very, very crucial. So now let's talk about the IES study plan. So IES is the program that we're going to use to investigate the design of the passive house. The study will be investigated in 3 seasons: winter, summer, and spring. 3 different days a year: December 21, July 21, March 21, and 3 different hours a day for each season: 10 a.m., 1 p.m., and 5 p.m. And also we will review all the design decisions by checking the standards from International Passive House Association criteria. At first, we're going to design a basic house with no passive strategies considered in it. First, the drawing is the site plan. So if you can see in the site plan, the long direction of the building is aligned with the long direction of the site plan. So solar orientation is not considered, just the shape of the plot is considered in locating the building. And the ground floor, in the ground floor we can see the living room, kitchen, and there's the stair. Also it was required to put a guest house, so basically there's a guest house, but it's randomly located in the location because we did not check any strategies, passive strategies for this building's design. And then in the first floor, we will have 4 bedrooms and 4 bathrooms with a family room. So those are the basic 3Ds of the building. We can see that in the ground floor, we have a large glass curtain wall. And then in the other rooms, we have small windows for the daylight. In this slide, we will discover the material used. We have used the materials based on the standards that are used in Barcelona. In the below chart, we can see the U values that they use in Barcelona. Basically, starting with the external walls, I've used single leaf brick wall with insulation and plasterboard with the U value of 0.40, and then I've used for glass or the glazing double double glazed with cavity with the U value of 1.4. And then for the roof, I've used a simple roof with a concrete deck of 100 thickness. The U value is 0.2791. The first result from IES simulation, we can see the heat gain. We can see the heat gain in the external walls are pretty high, almost 1000 kilowatt per hour. And the roof is maximum to 1800, and almost all the walls have the same heat gain. Now for the temperature, after closing the AC and the heating, with having a profile of opening the windows in the summer 40%, we can see that in March 21 it's 19 degrees minimum value and 24 degrees maximum value. In July 21 we have 22 degrees in minimum value and 29.9, which is very high in July in the summer. And then we have in December 21 we have minimum value of 15.6 and 20 degrees as a high value. As for the lighting, it is very important to consider lighting levels or daylight lux levels in the passive house design. For March 21 in the simulation for this building, we can see that in ground floor, guest house is almost dark in 3 hours, in three different hours, and in upper level, we have the family room pretty dark in the 3 different hours. As for July 21, we can see almost the same scenario as March 21 in the 3 different hours. We can see that in upper floor, the family room has the darkest range, and then the guest house in the ground floor has the darkest range of lux levels. Same scenario happens in December 21. We can see that in the ground floor, the guest house has the darkest range, and then in the upper floor, we have the family room has the darkest range of daylighting lux levels. In below charts, we can see that the lighting energy or the electricity lighting only consumes 6.9712 megawatts per hour in annually. And then the energy consumption for everything altogether, heating and cooling and lighting together, the building consumes 22.0535 megawatts per hour annually. Moving to the most exciting part is including the passive strategies in the basic design, so we can have enhanced building. The passive design strategies considered are the materials used, trim wall, solar orientation, ventilation, sun space, shading, and balcony. Starting with the materials used, I've used double brick wall instead of the single leaf brick wall in the basic house, which reduced the U value from 0.401 to 0.1495. As for the glazing, I've used triple glass instead of the double glass, which reduced the U value from 1.42 to 1.2735. And then for the roof, used a thicker slab from 100 to 150, which made the U value from 0.279 to 0.2640. All this were also compared to the passive house standards from the organization that I mentioned before. So we can see in the small diagram that the walls and the glass have the U values of a passive house standard. The next step is adding a trim wall. How do you add a trim wall? You can add a trim wall by adding a glass volume in front of your solid brick wall and opening vents inside your space. The trim wall in general, it helps with heating during winter and cooling during summer. The next step is choosing the solar orientation. The solar orientation of a project is one of the major and important design decisions to make. Since the climate in Barcelona gets cold in winter and really hot in summer, it is very important to investigate on IES view orientation's energy consumption before orientation decision. In down, we can see three drawings with three different orientations. The first one is longer glazing facade in the south, on the south face, and then the next one is the trim wall on the south facade, and then the third one is like the basic design aligned with the plot lines. So the next step is to see the energy consumption with heating and cooling open. So we can see which orientation has the best energy consumption or the reduced energy consumption. So we can see that the trim wall on south facade has the lowest, which is 17.3677 megawatt per hour annually. And then the next one is the longer glazing facade on south. Total energy consumed is 18.55, and then come the align with the plot lines. Of course, the higher is the one that with the basic design that didn't have any passive house strategies, which was 22.0534. As for the heat gain, we can see that the heat gain has reduced immensely comparing to the basic case, which we can see the walls are almost blue and they're all the same color. So the next step is to check the temperature without having any AC or heating open. So in March we can see that 23.92 is the minimum value and 24.61 is the maximum value. Comparing to the base case, in the base case it was 19.13 and 24. So basically the range in between the two numbers, the minimum and the maximum, has reduced. In July we can see that a minimum is 22 and then the maximum is 27. The maximum has reduced 2 degrees comparing to the basic, which is something good. And then in December we can see that the range in between the maximum and the minimum is very little, and it's in the comfort zone, because before in the basic case it wasn't in the comfort zone when it was in the minimum value of 15.59. As for the ventilation, knowing the wind direction will help to determine the locations of operable windows that can assist for house ventilation. So now we have the three wind roses of three different months, March, July, and December. We can see that in the summer we have we have a lot of wind coming, or the speed of the wind coming from the east is very suitable for having good breeze inside your house. And then we have a lot of wind coming from the south again also. In the winter and the cold climate, we can see that the most of the air or the wind is coming from the west, so it would be great to put some vegetation there or some trees that can help to direct the wind away from the building. This macro flow diagram shows the wind direction or the airflow inside the building in summer July 21. We can see in this diagram that the cold air is coming from outside and the hot air is going outside, which is a great result for an airflow. And also we can see that the trim wall is doing a great job of having the hot air going outside and then getting the cold air inside. For the next strategies, we're going to use adding sun space, balcony, and shading to the building. For the sun space, we have added sun space for the guest house, which helped with adding a lot of daylight inside the space, and then also it increased the temperature inside the space during the winter for a 19.83 minimum value and maximum value of 20.89, which is very good and it's in the comfort zone of a human being. And also adding a balcony for the family room, because the family room, as discussed before, it was not very good lit, and this also helps with lighting the space. Now checking the lighting results for this scenario, we can see that the lighting or the daylight lux levels has enhanced immensely, especially in the family room by adding the balcony. Also in July 21, we can see the lighting has enhanced the daylight lux levels in 3 different hours in the day, in the guest house and also in the family room. Same scenario happens in December 21 in 3 different hours. We can see that it has enhanced immensely comparing to the base case. Now reviewing the below charts, we can see that the energy consumption in the passive house for the lighting energy consumption has reduced from 6.9712 to 6.6112. As for the passive house standards reviewed, I've used International Passive House Association criteria. Below chart shows the criteria and the standards and the manual that they have. To check and review my design, I've used one of their standards to see if the energy consumption that I have designed in my building is good enough or not. So you can see that the standard says not to exceed 120 kilowatt per hour annually for per square meter usable living space. The designed building is 180 square meters, hence 122 kilowatt per hour multiplied by 180 gives us 21,600 kilowatts per hour, which is 21.6 megawatts per hour annually. As shown before, the building designed only consumes 17.36 megawatts per hour, which is lower than 21.6, and that's a good result. Thank you very much and have a great day.